Hi everyone, and welcome to the July session of Adelaide Microsoft IT Pro Community. Myself, Adam Fowler, and Brett Moffat may be talking to us from another country. We'll see which one's in now.
Hello everybody.
There we go. You want to say where you are, Brett, and what you're doing?
Yeah, I'm actually down here in New Zealand this week presenting at ITX, which is the it's a big conference down here in New Zealand. As part of the ITSMF New Zealand group that have asked me to come down here and present, which is very cool.
Cool. And now that we're testing new real abilities, we can actually have people watching remotely, seeing both the presentation and the video. You can do it on your phone. So we don't want to discourage people from actually coming to the sessions. But if there's a reason that you can't attend at some stage, feel free to message any of us and we'll give you a link to that this meeting. And we also are playing on recording now. So if you've got any issues with that, it will be recorded. Yeah, so it's quite cool. Let's move on. What's been happening? I'm just going to do a very quick, pretty interesting items. One being, has everyone now heard the news today of this new device? Yeah. No, it's let's put the title up there. Dropped off. What's it called? The Surface Go. Yeah. Which is, I don't know where they got the name from, but it's a 10-inch device. So it's trying to take on the iPad entry-level market. I think the same base cost for just that unit there is $399 US, and that's like 64 gig SSD, 4 gigs of RAM. It's got an Intel CPU. It's not Atom, but it's better. I think it's a 1.6 gigahertz. It's not a full I series. And interestingly, it's also fanless, so heat-wise should be pretty good. And yeah, same sort of surface things. You get the keyboard which attaches. Yeah, expensive pen. What's that? Sorry. You got USB-C finally. USB-C charging as well as the original Surface plug. So yeah, you might see some people bringing those in, going, can I connect this to our network now? I think they come with Windows Home, so that's not going to be great for Android, but we'll see how that goes. So yeah, I might start seeing around. I think they're a good idea to take on what iPad is doing. Oh, there you go. There you go, there's the specs. So it's a 10-inch screen, but these decent res. And it's also got the infrared camera, so you can use Windows Hello login for it. So yeah, well, I'm assuming a CIO or something at some stage will bring one in and ask you to set it up. One other interesting thing I saw was OneDrive for Business known file migration. Many people actually moved their users to using OneDrive for Business for their files. Show of hands if you have. Cool. So this is a new feature which you can enable through group policy. And it'll actually pop up for the user some screens saying, oh, you've got OneDrive for Business. Do you actually want to migrate your contents across? And it'll let you sort of pick your desktop documents and migrate and actually move them across to the OneDrive Business area and start synchronizing them across. So it could be a good way of getting some people to migrate over with less effort and putting the onus on the user to work out what they want on there or not.
Does that then continuously sync data from those selected folders from that point onwards, or is it like a
yes, and they've got the new icons that give you little cloud as well, so it's designed to sort of give the user a bit more information, saying, oh, that is cloud-based. It's off by default, so you have to group policy turn on. It's only just come out, so again, yeah, if you're looking at it, it might be useful. It sounds good to me. Those are the actually interesting things, because I wanted to keep a lot of time for our guest this week, this month. Rebecca Lyons. This is from LinkedIn, so I'm assuming it's still correct. Great. So technology solution professional, Azure application development at Microsoft. You're going to spend the rest of the whole time talking about serverless. I thought it was another slide, sorry. Go further with serverless. I'm interested to see this because I haven't seen the presentation myself. I'll let you get straight into it, but thank you very much for presenting. I look forward to the content. Thank you.
Sneak peek. Okay. Who here is mainly infrastructure based? Most people here are IT pros. Okay. I might go into a little bit of code today, but the majority of the time when I go into code, it's just to show you, hey, this is actually just a couple of lines of code. We're not going to go through line by line, so don't worry about that. But today I'm going to show you how to go further with serverless. So far, in fact, that it actually helps save lives. But before I go into that, I thought I'd give a brief introduction to myself, where I come from, my background, and what I'm passionate about at work. So I'm an avid gamer. I love gaming. I love open world games, and I kind of love open world adventuring as well. And this is a picture of me in the Canadian Rockies in a place called Jasper. It's actually one of the most beautiful places I've ever been. I love that photo, and that was a very zen time in my life. In my work life career, I have an Android application development background, so building Java applications and also a bit of web development. And I love creating, applications that work and feel and look great. And nowadays, I'm mainly talking about bots, and that's where that passion is taking me. But it's actually funny, before starting this role at Microsoft, which I've been in for about 2 years, the back-end side of application development, the configuration of servers, the configuration of networking, operating systems, and all the things that are integral in running and hosting your application, kind of was a bit of a love-hate relationship for me. This all changed when I got into the world of cloud and when I discovered serverless. I think Azure Functions went GA, I think, a couple of weeks after I started, and ever since then I've been absolutely hooked on the platform. And so today I'm going to be showing you how far the platform's come in the last 2 or 3 years, what are the features, what are the different services that you can use, and how you can put together all these services into an end-to-end solution without having to do all those underlying VM tasks. So a brief agenda of what we're going to go through today. I've kind of split out the presentation into 2 main parts. One's a bit of an overview of our serverless platform. So if you've seen, Azure Functions, Logic Apps, and Event Grid before, this won't be anything new. It will just be giving a brief overview of what everything can do. The second part of the presentation will be showing you how you can kind of interweave all these services together and build an end-to-end solution all on the serverless platform. So I've built a work health and safety solution, which helps detect people walking into factory environments and whether they're being compliant or not. And this is all built on the serverless platform, meaning in the whole end-to-end process, there's no VM, there's no operating system, there's no networking having to be configured. It's all HA, DR, all that stuff out of the box, and it's just a couple of lines of code to integrate each piece together. And I'll touch upon those integration pieces and how it all works in between. And now I've got a couple of links. So what I show you today is really interesting. Well, we've just released some documentation on how to build a very similar type solution yourself. Awesome. So let's kick off. And now I'm sure a lot of you might have seen a slide like this before. It's just showing you what are the different levels of control and responsibility as you go up each level into the cloud. So on-prem, to the left-hand side, this is what you're used to. This is all our responsibility. Everything under the hood, from the hardware to the networking, the virtualization, operating system, everything from the ground up. We have all the responsibility and we have all the control, but yeah, we've also have all the costs and the time to actually have to maintain everything in the stack. When we move into the cloud world, we get to offload a couple of those things to the provider. And so in the IaaS world, you're just outsourcing your hardware costs and your hardware management from the virtualization layer and down. A VM on-prem is no different to a VM in the cloud, except this is running out of a data center that we host and run for you. Moving a step beyond this into the platform as a service world, rather than you bringing your VM, you're just saying, hey, here's my application, or here's my data, Microsoft run this. And we'll run everything from the runtime and down. You just have to worry about your application and your data. Serverless kind of sits in between the PaaS and the SaaS side. It's not quite a SaaS product where it's just you pay for a user and you go, and it's not quite an application level thing. Because a lot of the time, what you're bringing in serverless is just your code or your logic, and that's it. You don't have to worry about an underlying application or an underlying infrastructure to run it. You just have components that you just need to run seamlessly and at scale, and the platform takes care of everything else. So what is serverless? Basically, the word says it all. It's just less servers. Less server management, less server configuration. configuration. It's just having your code and your business logic and having the platform maintain and manage everything for you. It's abstraction of servers and everything underneath it. It's all event driven and it's got instant scale, so you can go from zero use of these particular functions or your logic apps to thousands, and the platform itself will scale to handle this out of the box. And because it's not running all the time, we manage where it's hosted, how it's hosted, how it scales. If it's not being used, it's not going to be hosted, so you're not going to get billed for it. So it's per second micro billing for these particular services. Now, this is Microsoft's serverless application platform. In the core of what we do are our 3 different services, and these are the main ones I'll be going over today. So we have Azure Functions, Logic Apps, and Event Grid. Now, Azure Functions is your code as a service. So no longer do you have to worry about an underlying application, no more do you have to worry about an underlying infrastructure to run your particular methods or your particular classes. You just bring that as a function, you tell it when you'd like to execute it, you tell what data you want to bring in and output out on the other side, and we'll run it for you. So I'll go a bit into that in a second. Logic Apps is your integration platform as a service. It takes Azure Functions and adds another layer of abstraction on top of this, where you no longer actually have to go into the code, it's just a user interface to automate all your different steps in your workflow. Event Grid is where you can manage all your different events that are happening in your serverless applications. When we go to a more microservice architecture, when we go to building our systems with multiple different components, actually getting these components to talk to each other can be quite complex. Now, if we do it with, HTTP requests and webhooks, it kind of becomes a bit like spaghetti. And, this system's calling this system, and, what happens if you want to add another system to react based on an event? Event Grid basically decouples everything, all your events stream into Event Grid, and it will push out those notifications to your downstream services. And then we've got all these underlying services here that help just make these compute services useful. So how are you going to store your data as a result of these different actions? How are you going to add intelligence with cognitive services? So kicking off, I'm going to drill into a bit of Azure Functions. And for each of these different components, I'm going to give a brief overview. I'm going to go and see what it looks like on the portal. And then later I'll see how they will integrate together with my work health and safety solution. So Azure Functions, as I said, is code in the cloud without an underlying application or infrastructure to run it. They're event-driven. They're completely scalable. So you can go from 0 invocations to tens of thousands in a matter of seconds without any configuration to how that actually scales. It's all managed for you by the platform. How you develop your Azure function is no different how you develop your applications today. You can either write them in our browser code editor that we have, or you can bring them down, run them, compile them locally in your local development environment, and then push them up when you're ready. You can develop in languages C#, F#, Node.js, and we also have scripting like other languages like Bash, Python, PowerShell, etc. So if you have a particular PowerShell script that you need to run every day, just chuck it in a function, put it as a timer, and that will run every day a particular set of PowerShell commands. Binding into services is what gives Azure Functions its real power, and it's what helps minimize the learning curve and actually integrating with these different resources that you might have in the cloud. So we define everything, all these services in metadata and JSON, and so you don't actually have to specifically code the interface to each of these different services if you want to interact with them in your Azure function itself. So you can have an Azure function trigger by a new item being added to your service bus, or maybe something being added to Dropbox. Or you can choose maybe as a result of your Azure function to output something into one of these services. And these services are constantly growing, and there's a whole bunch of things you can do. Basically, there are 4 main programming concepts of a function. You have a trigger, and that's something that will start the invocation of the code. You have optional inputs that you can, go and grab a bit of blob storage and do something with the code. The code is where you actually do the important things in the function. That's what does it. You have all your business logic, and then on the other side, once that's done, you have an optional output. So let's go into the portal and see how this all looks. So I'm assuming everyone here has been on the portal before, don't need an overview, all good, cool. So I've just created a simple function for this user group. And all I've done to spin this up is go to create a new resource. I've said new function app. I've told it a data center to be running. I've put it a subscription for hosting billing purposes. And then it's created my function app for me. Within my function app, I can have multiple different functions that will get triggered based on different things that I tell it to be triggered on. So if I want to create a new function, I click the create button, and out of the box, I've got a couple of different templates that I can run with. So I don't have to code the interface to these different services from scratch. I can just build off what's already there. And if I turn on these experimental languages, I can see all the different languages that it supports. So I can have something in PowerShell, JavaScript, Python, Bash, Batch. I can have something triggered from an event hub, from a Cosmos DB, from IoT Hub. Yeah, this list is constantly growing. But for simplicity's sake, I'll create just a generic timer trigger. I'll write it in C#, my favorite language now. And then I'll say, okay, execute every 1 minute. So this is going to go ahead and create that. And every 1 minute, this is going to run that trigger. And so this little line of code is going to run. Now, this can be as complex or as simple as I want. Usually it's best practice to not have your functions too beefy, make them generally take care of one particular processing item at a time. That just comes down to how you architect things. But yeah, if we have a look at the logs, after about a minute, this will then spit out because this is running. There we go. So that's now run my function, and that's going to run every single minute. So this links back to those functional concepts that I showed you. This is my particular trigger, and the trigger is inputted in, and then I've got optional inputs and outputs as well. This is how the same function looks in PowerShell. So every 1 minute, my PowerShell function is going to execute that PowerShell function. So that's Azure Functions in a nutshell, and I'm only scratching the surface. There's a whole bunch more you can do with functions. So moving on to logic apps. So logic apps is similar to functions, except you can do everything and more all in a user interface. So you don't have to go into the code. It's your integration platform as a service where it automates your processes as a set of steps, those actions, in a workflow that looks a little bit like this. Now we've got over 200 different connectors that you can use to trigger your logic app and to actually call out to and get data in and out from in your logic app itself. So you've got two main components of a logic app, and that's where you bring your logic. So you might have control flow such as if-else statements, for loops, different paths, different exception handling cases, and you've also got your connectors. And your connectors are those things to get data in and out of your application, in and out of your workflow. So if I want to talk to the Dynamics API, I can do that with the Dynamics connector. If I want to go grab a list of users from Facebook, I can do that with the Facebook connector. The great thing about using connectors and logic apps is that if Facebook or Dynamics or any of these other providers choose to change their API, that's all managed for you by the connector. So you don't have to explicitly write the code or the connection to these different interfaces. That's all handled for you by the product itself. And here is an outdated slide of our different connectors. At the time, I think this is only a couple months old, we had about 130 different built-in connectors. These go beyond just the Microsoft connectors. We have a whole bunch of third-party ones, such as Google, Facebook, AWS, those kind of things. We now have well over 200 different connectors, and that list is growing. We have teams dedicated to writing and maintaining these different connectors, so that if there's a particular system that you want to talk out to from a logic app, most likely we'll have it, or send it a request and we'll build it. So let's go through what a logic app looks like. I'm going to go back to my home dashboard. I've already spun up a logic app ready to go. And with this, I've just said create a new resource, new logic app, which data center do I want it in, and that's pretty much it. Out of the box, it'll give me a couple of, because it's a new logic app, it would point me to some templates that make it easy for me to get started, similar to functions. So some of the most commonly used triggers to start the invocation of a Logic app. We've got event grid, if a new file is added to OneDrive, a HTTP request, if a new email comes into our Outlook, or a timer as well. Now here we've got different templates that you can use. One that we show a lot of time is, with tweets. So if you get a particular tweet about something, it'll save that tweet to a SharePoint list, for example. I'll use this one as an example. So send me an email when a new file is added to my SharePoint list online. I'm going to use this template. It'll go ahead and authenticate me against those different connectors. With the connectors, I only have to authenticate once, and then I can use and reuse them in all my different Logic apps. There we go. And it automatically creates this Logic app for me. For my SharePoint list, I give it a site address to where my SharePoint list is. I select a folder of where my items are coming from, and then it's going to use these different parameters that passes through in each step, and I'm going to send an email out on the other side. And now these different colored things are the different parameters that I'm getting from each step. So from this particular get profile step, I'm getting the email address, and I can pass through any different information into these different inputs from all my different steps. Now, the good thing about Logic apps is that it increases your development time, because it's very easy to add new steps or take steps away or add different flows in. So if I wanted to add a new step here, I just add an action, or maybe I can add a bit of logic, maybe a switch case, maybe a for each or a scope for exception handling. If I go and add in my action, you can get an idea of the different types of connectors that we've got. So out of the box, we've got about 290 actions you can choose to take. If there's something here that doesn't fit your specific need, you can actually go and create your own custom connectors yourself if you've got existing APIs. Or if there's a bit of custom logic that you just want to trigger off, that's when you can call an Azure function. So Logic apps is really good for orchestrating all the different moving parts of your serverless applications together. All right, moving on to Event Grid. So as I said before, with serverless applications, what we're finding more and more is, rather than having everything in your application in one big monolithic structured, big blob of business logic and calling out to different services, we're seeing more decoupling of different services into different platforms. So you might have a couple of logic apps running, you might have a couple of functions, you might have old APIs sitting on-prem, you might have new APIs sitting in the cloud. How do we actually get them to talk to each other, and how do we manage those connections between each of these different services? And this is what we can do with Event Grid. So Event Grid is where you can manage all the events that are, that your different serverless components are triggering in one place. So you have event publishers, such as blob storage, Azure subscriptions, or coming from your applications with custom topics. It'll then channel all those events into Event Grid. Event Grid will then push out those notifications to your downstream consumers of those. Now, what this means is that the publishers and the subscribers of those events, they're completely decoupled. So you can add new subscribers to those, or you can add new publishers to that. And it means that you don't have to, if you change something in one system, you don't have to talk out to another system. The other good thing about it is that it's a push-push type model rather than being a push-pull. So if you've used something like Service Bus or Azure Queues, usually with your downstream services, they have to be constantly polling that queue to check if anything's changed. With Event Grid, it's push-push. So your subscribers, your publishers, they push an event to Event Grid. Your Event Grid will then push via HTTP a notification to those downstream consumers of that. So if you're running your different business logic in a Logic app or an Azure function, they don't actually have to be constantly polling, constantly running. They can just be sitting there, not being used, not being built, and it'll only start up once an event triggers the invocation of that particular service. Now this is just a snippet of what it looks like to create an Event Grid topic. So you say what you'd like to be subscribed to, what you'd like to monitor, and that could be any Azure resource that you have, or it could be a custom topic, which means you can talk out to Event Grid from any application that you can talk over HTTP. And then you point it at your event handlers. You can have one, you can have many different subscribers to events. Because it's decoupled, it just means that you've got more flexibility in adding and removing those particular subscribers. And then you can do some smart logic above this with filtering and routing of events to different services. Basically, it's a good tool for your serverless-based applications. Okay, good. Awesome. So that kind of gives you a brief overview of the different components of our serverless platform. And if you're running everything in a serverless platform, that's great, but how do we actually make it useful? And that's how do we store our data, how do we secure it, how do we inject intelligence into that? And that's where these underlying services come into play. So you'll see a little bit in the demo that I'll go over it shortly, how I talk out to different database systems, how I talk to storage, and how I inject intelligence with Microsoft Cognitive Services. Now, I'm not going to go over too much of what cognitive services are, but in my solution, my work health and safety solution, I'm using two particular APIs under the Cognitive Services suite of APIs. So I'm going to be using the Face API and the Computer Vision API. What the Face API does is it's facial recognition as a service. So I send up an image via an API, and it will give me a bunch of information about that image. It'll tell me, hey, this face is in this particular coordinates of that image. It'll tell me, I actually know who this face is. It is blah, based on how I've trained it and retrained it before. Computer vision is like if you gave a computer eyes. If I took a picture of you guys right here, it would tell me, okay, this is a room full of people watching a presentation, for example. It just reads out what it thinks is an image based on what it's learned before from previous data. So I've used those two APIs to help improve work health and safety in one of my customers. And then to the left-hand side, you've got all your different tools that are inbuilt to these services. So in the brief overview that I gave you of the different tools, I showed you how to interact with them from the portal itself, but you're not locked into just staying in the portal. You can use the tools that are native and that you use in your day-to-day development. So you can write functions from your local IDE. Same with logic apps, you can create your logic apps from Visual Studio. They all integrate into DevOps. Everything can be defined as an ARM template, so you can check everything into source code repositories. You can monitor them with App Insights and Log Analytics, and you've got some good visual debug tools and history that you can dive into, which I won't touch on today, but it's good to know that you've got options for developing against these particular services. Awesome, so let's go into the meaty part of the presentation, and that's how we save lives with serverless. Now, I don't think I've saved any lives yet, but the solution that I'm going to go over helps improve work health and safety in a factory environment. So, what is the problem that I was faced with? So, I have a customer in Melbourne. They are a manufacturing customer, and work health and safety is their #1 priority. What they were finding is they have multiple factories with multiple workers, and they were finding it very difficult to ensure that their workers were being compliant on their work floor environments. And these environments, it's a manufacturing environment. So they've got dangerous equipment, they've got heavy machinery. They want to make sure that everyone who are in their factories, who are in their workshops, are they're authorized to be there, they've done their onboarding training, and they're actually allowed to be in the room. And two, that they're being compliant. So are they wearing their safety hat, and are they wearing their safety gear? And they also wanted to utilize existing commodity hardware to be able to, monitor and get insights into all the different factory environments. And so we tackled this problem with serverless. And this gives you a brief run through of what the solution looks like. And they've actually rolled this out to one of their sites, and they're planning to roll it out to more. So what the solution does, it uses just commodity hardware. Right now it's just using a laptop when a worker walks up to a door. If they're not recognized and if they're not wearing their safety gear, it's not going to go and let them in the room. And that's actually hooked up to IT, so it's actually hooked up to whether the door unlocks or stays locked. If a worker puts on their vest, that's great. It'll recognize the vest, but it's still not going to let them in. If if a worker puts on their hat, that's great. It's going to know that they're compliant, but it still needs to know, are you authenticated to be in this room? Do we recognize you? Are you in our Active Directory? Once it knows the person, it knows they're being compliant, that's when it's going to let them in the room. And so, a floor admin or one of the managers knows that everyone who's on their floor at that moment is compliant and is known to the system. And this is what it looks like behind the scenes. So I've used every single component that I mentioned before of the serverless platform, and I've used them in particular places for different reasons. And I hope just in going through this, you'll be able to get a couple of my learnings and why we use some of the services over others, because that's what we find a lot when moving to cloud native solutions is that there's 100 different services that you can leverage. Why would you use one over the other? So basically, we've got the solution, a very thin client, which is making a HTTP call to my Azure function. This is where the majority of my API calls are made. And we decided to put everything in an Azure function because there was some complexity in the business logic. There was a bit of threading that we had to take into consideration, and that all worked well when we had control from the code level. That's making the different calls to my cognitive services. So I'm getting an image from that thin client. I'm calling the face API to detect the faces in the image. If there's no face, throw an error. If there is a face, okay, move on. Let's identify who it is. Do we recognize that person? Are they in our system? If not, throw an error. If they are, okay, let's recognize, are they wearing their safety gear? If they are, that's great. Let's let them in the room. If they're not, let's send them a notification to put on their hat. And that's kind of the basic premise of how the Azure functions work. If anything goes wrong, or there's an alert or an event that happens, so if there's no face, if there's no recognition of that face, and if there's no safety gear, that's going to then channel those events into my event grid system. Now these events will get pushed into event grid, and then I can have any different subscriber subscribing to that endpoint and then processing those notifications. In this case, I'm just very simply taking those notifications, I'm triggering a logic app. Logic app's going to save that into a SQL store, which has all my different notifications. And then once I've got all this data in a data store, I can interface that however I want. I can have all those notifications streamed through a live notification portal. I can put it through a Power BI dashboard to get nice graphs of actually who's in my room, who's not, who's been compliant, how many times have people tried to enter the room and they're not wearing their safety gear. That's pretty flexible, but basically the first little bit of this solution is what I'll be going through each day. Now, the beauty of serverless is that it's scalable and you don't have to do pretty much to get it to scale for you. So this means that I can have this deployed once, running out of my local computer. I can have it deployed to multiple different sites, multiple different computers. Because it's a thin client, it's just a HTTP call. It doesn't have to be coming from a laptop. I can trigger this from my mobile applications, from a desktop, or just from some smart commodity hardware. So there are actually cameras out there that can make HTTP calls and pass images up. So this particular solution can get triggered from everywhere, and it can scale to meet that demand. So I can have no people walking into my room, or I can have hundreds, and the solution will automatically scale. And because of the serverless platform, it's all highly available, it's disaster recoverable out of the box, with no needing to go into the VM to configure networking, the operating system, and all those different components. Awesome, so that's the solution in a nutshell. I'm going to go into each individual component to show how everything kind of fits together. And the main premise of this is just to show that it's not a whole bunch of code to make all this work. It's usually a couple of lines of code or a couple of configuration files that you've got to hook up together to get all this working. And the great thing about this is that I'm not a team of data scientists, I'm not a team of developers, I'm just one developer who's put this all together and solved a real-world problem. And so it kind of shows how approachable these different solutions are and how they all integrate together. Awesome. So, first thing I'll go on to is what the solution actually looks like. Here we go. Alright, so I've just got a very simple static website here, a little bit of JavaScript. All it's doing is making HTTP calls to my Azure function. So, if I start detecting, it's not going to see my safety hat, so it's going to flick over to false. And then it's not very pretty, but you can see now it's flicked over to false, and now it's flicked over to true. There we go. So what this has done, it's recognized who I am. It knows I've been trained to the system, so it knows, hey, this is Rebecca Lyons. It's up to then whatever system to unlock the door based on if I'm in the Active Directory or not. It said, hey, this person is wearing their safety hat, but they're not wearing their safety vest. And the reason I'm not wearing my safety vest today is because I left it in Melbourne. So there we go. Usually, if I have my safety hat, I have my safety vest, a big tick comes up, but fortunately I didn't bring my gear along. So I'm not being very compliant today. And that's pretty much the very simple interface that I've got here. This is all static HTML, JavaScript, and CSS. HTML, very basic. It's just a couple lines of code here. All it's doing is making a HTTP call. Won't go too much into the code, but yes, this is my function URL, and I'm just hitting that, passing up the image that I'm capturing. So this is sending up an image every 1 to 2 seconds. So every 1 to 2 seconds, if something changes, it's gonna flick the switch to true, false. We don't recognize this. It's recognized, that kind of thing. Why this is good to have everything HTTP based is that it doesn't matter what particular interface or front end that you have, you can call it from anywhere. Before, in phase 1 of this particular application development, this was all integrated into a UWP app, so it was very much tied to the Windows system. When it came to actually wanting to roll this out and deploy it to the general factory environments, it meant that they needed to have a particular Windows laptop to run it. Moving all the business logic out to the cloud and making it callable just from a HTTP means that you can call it from a couple of lines of code in a static HTTP JavaScript website. Now, one thing that we've just got GA with, it's a public preview with, is static website hosting in blob storage. Now, because this is a very thin client, it's not doing any server-side processing, I can store this in blob storage and serve those files out of that without having to pay for any large cost underlying infrastructure like VMs or an app service. So, in actually hosting those particular files, here. So I've just got a storage account here, and a storage account is where you can store, your blobs, your queues, your table files, and storage is one of the cheapest things that you can do on the cloud. To host these files up, which is just a HTML page, a CSS page, and a JavaScript page, I go to the static website, little toggle here, I click enable, and this is going to present me a public endpoint that I can serve my files out of. So this gives me that static web SA web.core.windows.net endpoint. If I want to upload my files, I can do this programmatically, or I can upload them here. So I'm going to blob, I've got my web container here, and here I'm just serving my static files out of. So it's very simple, index, main, and CSS and main JavaScript. And that is what you see when I have my application. So that's running from that endpoint, and that's just running out of blob storage. And it's a really good pairing to have, a very thin, dumb front end of your applications and have all the server-side compute happening on a serverless, infinite scale type platform. All right, so let's move on to the function, which is where all the magic is happening. So I've touched on what a function looks like from the portal itself and the code editor that we have here. But as mentioned before, you can pull down that code, you can run it and compile it locally in your local developer environment, and then push up later when you've tested it and you're ready to actually make it go public. So this is what I've done here. So I've got my function, which is read only here. And this is where I've developed it in my Visual Studio environment. So I've got two particular functions, one for image analysis and one for onboarding and retraining the API. Won't go into the code again, but basically you can see I've got, my different calls that I'm making, and this will just run every time that HTTP post goes through. It'll get the image, it'll call the face API, it'll call the computer vision API, and then if anything happens, so if there's no gear, if there's an unrecognized face, then it's going to go send an event to my event grid, and it's going to give a response back to my front end so I can display that in the HTML. That's probably how I'll just stick with that for the Azure Functions, but I thought I'd call out, this is what it takes to call out to an event grid. And it's just a couple of lines of code, it's just a HTTP call. So basically any application that can talk out to HTTP can create an event grid. So you can have all your different services running in different stacks, different languages, they can all be talking to event grid. An event grid can be that one place where you manage all your different events. So in this case, I'm passing two main events, two main notifications, and that's if I'm not wearing any gear, or if someone's walked into the room and it doesn't understand or recognize who they are. And this is what it looks like from a minute. Maybe I'll just do a brief recap of what I've shown so far. I've shown the thin client on this side. I've shown the Azure function, which makes all the calls to the cognitive services. And now I'm showing what happens after those events get streamed into event grid. So this is my event grid. And once again, to spin something like this up, I've just gone new resource, event grid, and I've created a new topic. I can send events to that topic, and then I specify down here who are my subscribers to that particular topic. I've got different metrics, so I can see how many were successful, how many failed, and lots more. I've got the keys, and there's lots of different things I can do here. Yeah, so basically I can see all the different events coming through my event. It's what happens to these events once they're in there that's really important for this particular system, and that's all done with logic apps. So this is my logic app, which picks up that event when it occurs. It does a bit of filtering, so it says I only care about events that have an event type no gear or unrecognized face, and then it's got a bit of logic in here to switch case to say, okay, if it's no gear, then I want to save this into my SQL database. It'll save a particular notification in. If it's of an unrecognized face event, it's going to save just a little bit of a different notification there as well. And then I can run and save this, and that will get triggered every time an event gets pushed into my event grid. And then that gets saved into my SQL database. And then on the other side of that, I can interface that however I want. Now, for this particular customer, they cared about their system admin and floor admins who manage the space. They wanted to present this information to them in a way that gave them the insights into who's in their room, who's authorized, and how can they actually go and contact these people who are on the floor. And so I gave a couple of ways of interfacing with this data. I put it on a website, where I gave it a stream of those events coming through, and also interface it with a bot, which is pretty cool. So here is, the other side of the application. And this is where, a manager or a floor admin would really care about. Now, as you can see, there's a lot of me being uncompliant. I've walked in and out of the workshop environment without my safety gear quite a bit in the last couple of weeks and days. So yeah, but lots of different notifications coming through. Another way of training in members to the system is capturing those different images. And this is one of my colleagues that they've walked into the room, has understood who they are. I can be a floor admin, see all those different frames of the faces that it didn't understand, and then use this to retrain the face API. So that next time this person walks into the room, it's going to understand, okay, this is this person here, this is their role, this is their number, Are they authorized? Go and say retrain it. That's actually an Azure function that's doing all the retraining itself. So yes, that's one way of how an admin can have access to actually train and make things smarter over time. This is my bot that I've interfaced all that data with. So I can say hi to it. And this is talking to the same SQL database in the back end. So once this wakes up, I'm going to say, hi, what can I do? I'm going to say, okay, bot, who is active at the moment? So who is in my factory environment? Who's logged on? Who's authorized? Who's being compliant? And so far, it's only been me who's walked into the room. So it's only going to know, okay, their client is active. I found one person. And from here, I can choose to go and call them. This could be a Skype call, or this could be any other service that they're using for calling. And so I can go and actually call my active users. Or I can ask it different questions, and it can actually hook into, your Active Directory credentials, such as, all right, who is authorized to use a jackhammer? This is using Lewis under the hood, which is Language Understanding Intelligence System. Lewis understands intents and entities, so I don't have to type everything perfectly. I think I made some spelling errors. It understands that, okay, someone's trying to find someone who's authorized to use a noun jackhammer. And it says, okay, I found 19 people in your organization who are authorized. This is down here. But I've also detected that, this has gone in a different order, but it's detected that their client is active right now. So it's giving a bit of smarts around your data. And this is all the same SQL database under the hood. There we go. If I want to call their clients, I can. Just call my phone. And that's the end-to-end system, and that's how everything works under the hood. And this took about a week or two worth of development to put it all together, and now it's been rolled out to all these different workshop environments, which is great. So some of the learnings that we took from this. Phase 1 was monolithic. It was all in a UWP app. It was large, it was clunky, it was hard to roll out. We moved and we ripped apart all the business logic that was actually doing the image processing, put this on the serverless platform, and now it can run from pretty much anywhere that can make a HTTP call. We chose to use functions to run all the complex business logic, and everything else that a business admin might want to tweak or use, we put those into the logic app. We were originally using Service Bus for our queuing and eventing system, but our logic app had to actually poll that every time, which is costing me money. So we moved it to Event Grid, and we saved a lot of cost by using the push-push model. And there's a whole bunch more learnings, but basically overall, we leveraged the service platform, and now in rolling it out, nothing really has to change in the underlying services. It's just a case of, okay, what are we going to run it from, what device are we going to use, and that kind of thing. There we go. So that was one particular scenario for serverless, but there's a whole bunch of other ways that you can integrate it into your systems today. So, for any timer-based processing, you can do that. So if you want to do a database cleanup, every 24 hours, trigger that in a function or in a logic app. Real-time stream processing, it works great with IoT with lots of different events coming through. For backend, for mobile, IoT, and web, similar to what we've done with the work health and safety one. If you're generating images, send them to blog, do different things with the serverless platform. Bot messaging is also one way you can interact with serverless from your applications. One of the inputs and outputs of an Azure function is to a bot. So if you want to continue on the conversation with a bot and get the serverless platform to do all your heavy lifting for you, you can do that. And then because it knows what bot started the conversation and where the conversation needs to go, it'll seamlessly integrate back into that conversation when that particular processing item is done. And where to start? So if that was interesting to you and you thought, okay, I'd like to find out a bit more how all that's put together, we've just released this bit of documentation going through how to create a serverless web app. A serverless web app in Azure. Now, this is a great link, and it goes through pretty much a very similar solution to what I've gone through today. And what it looks like. Cool. So It'll give you a very simple static website that you can go and run, pull the code from GitHub, and host it in blob storage. So you've got your host, so your web pages there. You're saving your image in blob storage, and then you've got a couple of different Azure functions doing a couple of different things. So uploading the functions, calling computer vision, calling out to a logic app, saving it in Cosmos DB, and then authenticating with Active Directory. And that goes through it step by step, and by the end of it, you'll have a serverless web app running, just simply like that. So yeah, I hope I've imparted some of my passion of the platform today. Let me know if you want some more links and some more information. But yeah, definitely encourage all of you to see what it can do and how you can integrate it with your applications. So thanks.
Are there any questions? No?
Yeah, any questions?
I do. When you were creating the apps, it looked like it was created against your user account on Azure. Is that possible to create them against service accounts or non-specific accounts?
Which app?
Sorry, I think I can't remember which aspect of it exactly. The logic app, yeah.
So everything in Azure can be filtered down to role-based access control.
Yep.
So you can give access to particular resources or particular privileges based on who you are. So you can have particular users who are allowed to create resources, and you can share access to those resources to your team, or you can use service.
So were you talking about where the logic app has it connected to the SharePoint Online?
Oh yes, and stuff like that. Like which, how does the like is it only tied to one account? Can it be?
Yes.
If we don't want to have it only on one account, can we tie it to a service account, like a group managed service account, for instance, or something like that?
Yeah.
To run it instead, that sort of thing. Like,
Yeah, for something like logic apps, you can definitely do generic accounts. It just
Okay.
depends on what connector you're using and whether that's allowed in the actual service itself. Yeah.
Can you secure this whole thing? Like, can we? Because I know it says HTTP, but what if we need to do HTTPS and then data at rest, data in motion?
Definitely there are ways to secure this down. Each individual service handles it a little bit differently, but if you want to add that extra layer of security on top of it, that's when you can hide all your APIs or your endpoints behind a service like API management, and then they'll put a secure endpoint in front of it, and then you will authenticate API to your different services, and then configure how you want that to work.
You can buy certificates themselves inside of Azure as well. So if you're over, it's almost totally self-contained.
Other than do I think most of this is yet in the protected classification level, ASD, but some of it is, because I think storage accounts work. So that would mean the static web content is doable. And I think Cosmos is going through certification.
Is the cost dependent on the APIs that you're using? Like
For logic apps, yes.
yeah, so if you're using like the face recognition, I can imagine they'll probably use more processing power than like a timer, for instance, something like that.
Yeah, so for functions, it's per second billing, so just you're paying for compute.
Yep.
For logic apps, it's per billable action.
Okay.
So each one of those steps in the logic app is a billable action,
Okay.
and they're 0.000 something
Yeah.
cents. It depends on what particular connector you're using. So if you're using one of the enterprise ones like SAP, then that'll be more expensive, whereas some of the ones that come out of the box, like the HTTP trigger, and ones like that.
Okay.
And your cognitive services for computer vision, off the top of my head, it's about $1 to $2 every 1,000 calls.
Okay.
Is there like a pause option for functions? Like if you need to do an enhancement to the code base,
Yeah.
Can you just like
You can
pause
just
it,
say,
input while you change it, and then turn it back on?
Yep, so there's a little toggle here. This is because I put it up into source code repository, but if you're using the code browser, you just go status, disable, or enable.
Any other questions? Cool. So one other, I guess, point of interest is Thursday you're also presenting at the Reborn Azure user group. What's the session on Thursday about?
So the session on Thursday is mainly, okay, so we've got this cloud thing, how do we actually learn about it? How do we skill up? What are the different areas we can go to educate ourselves and get free resources? My particular part will be talking about that from a developer's perspective. So how as a developer do I start using those products? Do I learn how to use them? And where do I get help if I get stuck? So
Cool. So if it's any interest or you know someone, the Azure use group is not connected to us in any way, but it's run by Microsoft at the moment, and thanks for presenting. So I hope for it.
not the whole bit, there's other presenters there.
Other bits and pieces, I think it's at 4 o'clock as well.
Yes.
So otherwise, that was awesome. Thank you very much. Hopefully we can convince you to come back another time. I know you've got several talks you can do, so we might send out the survey and see what people are interested in. Hopefully we can convince you.